All right, hi again, you guys. So today we are carrying on with kind of what we started in the last lesson, which is section 5.2 out of the textbook. But last time we looked at multiplying radicals, and today we're going to extend that into dividing radicals. So just the way we did last time, we're going to start out with a little bit of an investigation where you are given a question. So we have 4 cube root 6 divided by 2 cube root 3. And you're given the answer here. And again, I would like it if you pause the video now and see if you can figure out, if you know that this value is being divided by this value, how do you think logically those numbers would connect to give this answer? So see if you can figure it out, and then restart the video and we'll go through the solution. So if you went through it, probably you could figure out what we end up with is a coefficient of 2. And what we have here is a coefficient of 4 divided by a coefficient of 2. 4 divided by 2 is 2. Okay, so that seems pretty logical. What about our radicand? Well, we start out with a radicand of 6 divided by a radicand of 3, and we get a radicand of 2. So does that make sense to have cube root 6 over cube root 2? Cube root 3. Oh, now I've put my white out somewhere. There we go. Cube root 3. Does it make sense? 6 divided by 3, what do we get? Cube root 2. Makes sense. And so our final overall answer for this would be a coefficient of 2 and a radical of cube root 2. So 2 cube root 2. Seems like it probably makes sense, right? Especially it's a little bit simpler than the one we looked at for multiplying because you didn't have to do any simplification. So what were the steps that we needed to take in order to get that solution? Well, basically we needed to divide our coefficients and then divide what was under the radical sign. Just like with adding and subtracting and multiplying, we have kind of the same rule where you need to remember that you would have to have the same index for any radicands that you're dividing. So that's just one thing to keep in mind as we move forward. Okay, so let's have a look at some information before we go into some examples. So when you're dividing radicals, you divide the coefficients, then you divide the radicands, and like I just mentioned, you can only divide radicals that have the same index. Okay. So in general, what we could say is if we have, our values of our coefficients, our values of our radicands, and our indexes are the same, so represented by the same variable here, we can say that this setup is equal to the coefficients being divided by each other multiplied by the radical with the same index, and underneath that radical we have the two different radicands being divided. Now, a couple of things to pay attention to. Remember, we talked about how if you have an even index, we can't have a radicand that is less than 0. And so basically for any setup, our numerator has to be greater than or equal to 0. And the value on the bottom has to be greater than 0 because remember, you can't divide a number by 0. So that's why it's not greater than or equal to. Okay. The other thing is that our coefficients, neither of them can be equal to, our coefficient on the bottom, again, can't be equal to 0 because if it would multiply through, we would have an error because you can't divide by 0. And yeah, same thing here. So our denominator radicand can't be a 0 either. Okay, but that's kind of what we said there with the b has to be greater than 0. Okay, the other thing we kind of need to be aware of is the concept of rationalizing a denominator, which we're going to use quite a bit as we move forward. So basically what rationalizing a denominator is simplifying an expression that has a radical in the denominator. So if you have a radical that's set up like a fraction and you want to simplify, for like multiplying and stuff and adding and subtracting, we've simplified pretty easily just by factoring our radicand and moving whatever we can out into the coefficient. With Fractions, it's a little bit more tricky because basically what you need to do is make the denominator into a rational number. So that's going to be just a whole number like we see here. And in order to do that, basically what you need to do is look at what is your radical that is in the denominator. So remember, denominator is on the bottom of a fraction, and you need to multiply your entire fraction, so the numerator on top and the denominator on the bottom, by just this radical. You don't need to include the coefficient. So for this one, 5 over 2 root 3, if we want to simplify it, the radicand on the bottom, or the radical part, is just the root 3. So we want to multiply our entire fraction by root 3, top and bottom. So if we do 5 times by root 3, we end up with 5 root 3. And if we do 2 root 3 times by root 3, remember what we talked about last time, when you're multiplying roots together, you basically cancel out the radical sign. So root 3 times by root 3 is going to give us just 3. So we end up with 2 times by 3, which gives us 6 on the bottom. And then this value, the numerator value, could not be simplified further. So our simplified version of 5 over 2 root 3 is 5 root 3 over 6. So we want to keep that whole number on the bottom in our simplified fraction. Okay. Now things can get a little bit trickier because with this one, all we had was the one term on the bottom. But sometimes we're going to have a binomial term. So that's where you have a 2-term denominator. So there's going to be more than just this one radical. And if it contains a square root, you need to rationalize the denominator a little bit differently than we did here, because what you need to do is multiply the denominator and the numerator by a conjugate. What is a conjugate? Well, conjugate is basically, if you remember when we did factoring with a difference of squares, if you had, for example, bracket x plus 3 multiplied by x minus 3, those are conjugates of each other. Okay, and so when you're rationalizing a denominator, if you had like x plus 3 underneath, for example, you would need to multiply the denominator and the numerator by x minus 3. So basically just the opposite operation. And we'll look at some examples as we move forward, so that'll hopefully become more clear when we go through those. Okay, so let's start out with some nice simple examples here. So in the first one, we have root 80 divided by root 10. So all you need to do with this one is think about how would these numbers divide, just the way you normally would. So if we have 80 divided by 10, we know that 80 divided by 10 would be 8, and they have the same index, so we can just divide them like that. Now, it's asking for us to express our answers in simplest form. So we just want to break this down as much as possible. So 8 is 4 times by 2, and 4 is 2 squared, right? So we have one squared value, and remember the squared value can always be square rooted and moved outside the bracket. So 2 squared square rooted is 2, so it becomes our coefficient. And then the only thing that's left inside the bracket is another 2. And so that's our simplified version of root 80 divided by root 10. Okay, our next one, we have coefficients this time. So we want to break them down. One thing you can do here is think about just like simplifying 2, right? So negative 2 divided by 4, if we simplify that by dividing them both by 2, we end up with negative 1 over 2. Right, so negative 2 over 4 is basically negative a half. And then what if we think about root 12 divided by root 3? Well, 12 divided by 3 is going to be 4, so we want to keep that underneath the radical. And because we've divided the 3 into the 12, remember we have no remaining radical on the bottom there. So now we have this set up, and all we need to think about is, can we simplify this radical? Well, the square root of 4 we know is 2, so basically we end up with negative 1 times by the square root of 4 is 2, and then we divide it by 2. And negative 1 times by 2 is negative 2 over 2, and negative 2 divided by 2 gives us negative 1. So that is our very simplified answer. Okay, last one here. So we have 3 over 3 root 135 m cubed divided by root 21 m cubed. So no coefficient on the bottom to divide it out by. And then even with this one, if we look, let's have a look at 135 divided by 21 just to see if it works. It gives us a decimal value, so we don't want to do that. So if you find that you're not going to be able to divide these numbers into each other evenly, what you want to look at doing is simplifying either or both terms depending on how they are. Like, so with 21 we can't simplify it because it's 7 times 3. Neither one of those is a squared value that we could move outside. With the 135, let's try dividing it by 5. So basically 5 times by 27 would give us 135. So if we break down 27, we know that 27 is 9 times by 3, and 9 is 3 squared. So there's our squared value that we'll be able to move outside. The 5 and the 3 are going to have to stay inside the radical. So if we were to simplify this, it would be 3 root 3 squared times by 3 times by 5. So those are our factors. And then we still have the m cubed. And then on the bottom we have root. Sorry, I should have extended the radical sign there because all of that was underneath it. And then 21 can't be simplified, and we have m cubed. So now that we've looked at dividing out the number values, we can look at, can we divide these out? Well, m cubed divided by m cubed is going to be 1. Any number divided by itself is 1, so we can basically cancel those out. So now if we look at simplifying, the 3 squared is going to jump out here and be multiplied by the 3 that was out front. So remember, that's going to be 3 times by 3, which will be 9. And then underneath the radical on the top of the fraction, we still have 3 times 5, which is 15. And our m cubed was canceled out. So we have 9 root 15 over root 21. Wait. Oh, I was just thinking, why did I have 15 there? How was I going to factor that out? 9 root 5. That makes a lot more sense. Oh, because I had it multiplied through. Never mind, sorry. So now actually the one thing that I forgot about here was, and maybe I should have done this in the previous step. So with the 15 and the 21, remember that 15 is 5 times by 3 and 21 is 7 times by 3. So again, we do want to look for like terms on the top and bottom. There's a 3 here and a 3 there, so those can cancel out and we can be left with even more simplified as 5 and 7. So our final answer then would be 9 root 5 divided by the root 21 got simplified to root 7. So that would be our final fraction there. Sorry, that got a little bit messy there because I extended it out because I forgot about accounting for those 3's. But yeah, so that would be our final answer. What you could have done too here is you could have expanded this in the first place, and that might be the easiest thing to do moving forward, is always expand everything, even if you know that you can't factor this down, because then you could look for the like terms in the first step to cancel them out. Sometimes the variables are a little bit easier to spot, so then that's why it might be nice to expand out those numbers, which is what I did in the filled in notes. So if you look at those, you'll see that method laid out there. Okay. Next one is rationalizing denominators and then expressing in simplest form. So remember, with rationalizing, we are multiplying the top and the bottom by this radical that we see on the bottom. So basically, we're going to multiply this whole thing by root 10 over root 10. So 20 times by root 10, 20 basically becomes the coefficient, and then we have root 10. And then root 10 times by root 10, remember, if you do 2 square roots multiplied by each other, you're squaring them, which essentially gets rid of the square root sign. So we end up with 10 on the bottom. Okay. Oops, I forgot the 0 there. I put in 2. It should be 20. Okay, so 20 root 10 divided by 10. So now the only thing we would look at is, can we simplify anything? There's obviously not a radical on the bottom because that's what we were trying to get rid of. But these two values, the coefficient up here, can be divided into this one. So 20 divided by 10 gives us 2. And that gets rid of the fraction. And then we're just left with our radical. So 2 root 10 is our final answer for that one. Okay, let's have a look at this one here. So we have negative root 21 over 2 root 7m. And so let's see if, first of all, let's see if we can divide anything out here. So negative and 2 can't be simplified anymore because remember this is technically like a negative 1. So negative, but with our 21, remember 21 is going to be 7. Whoops. 7 times by 3. And down here we have a 7. So these two 7s can cancel out. Oops, sorry, I'm on a bit of an angle there. Okay, and so then we're left with underneath this radical just the 3. So root 3 divided by, on the bottom we're going to have 2 root m. Okay, so it's nice if you can simplify first because now when you're multiplying through, in order to rationalize, it's going to be a simpler multiplication. Otherwise you would have to simplify at the end. So now our radical here is root m, so we're going to multiply top and bottom by root m. So now 3 times m is just going to be 3m, so we're going to have negative root 3m. And then on the bottom, these two multiply through to just make m, so we end up with 2m. And is there anything else we can simplify? Because this m is not under a radical sign, remember you can't simplify it with this m which is under a radical sign, so it seems like that would be the simplest version that we can get down to. Okay, so now we're going to look at that step that's a little bit more complicated that I talked about, which is looking at a conjugate. So let's first of all work on what is a conjugate. If we have root 7 plus 4, what would be our conjugate of that? So if you remember on our previous page, the conjugate of x plus 3 is x minus 3. So the conjugate of root 7 plus 4 is going to be root 7 minus 4. Okay, now when we have a conjugate like this, if you were multiplying it through the way we did here, you would have to expand it and simplify. So we want to do that here. So you're going to use FOIL again. So remember, first terms multiplied by each other. Root 7 times by root 7 is just going to be 7. And then FO outside terms. So root 7 times by, remember to keep that negative with it. So negative 4 root 7. And then inside terms, so positive 4 times by root 7. And then last terms, so plus 4 times by negative 4, positive times by negative is negative 16. And then what we can see here, whenever we multiply like identical conjugates like this together, you're going to have negative of one like coefficient together with its radical, and then positive, and so they're going to cancel out, right? Because negative 4 root 7 plus 4 root 7 is 0. So we end up with just our first term here and our last term here. So positive 7 minus 16 gives us negative 9 as our final answer. Okay, and so that's why we're using a conjugate when we when we have a binomial like this as our denominator, because it brings it down to a whole number, which is what we're always trying to do when we rationalize. So let's try that with an actual fraction setup here. Ooh, look at that good spelling mistake there. Dominator, denominator. I'll have to go in and fix that. So we have 2 divided by 3 root 5 minus 4. So in order to rationalize this, we are going to start out by putting in the conjugate. So 3 root 5 minus 4 is going to be multiplied by 3 root 5 plus 4. Okay, and remember we have to do that on the top and the bottom. So 3 root 5 plus 4. So you're going to have to make sure you multiply through by all the terms. So 2 times by 3 root 5, you're going to multiply just the coefficients together. So we're going to have 6 root 5. And then we have to multiply the 2 by the last term. So 2 times by positive 4 gives us positive 8. So that's our top term. And then on the bottom, this is where we're going to get a little bit more involved. So 3 root 5 times by 3 root 5 is going to give us 3 times 3 is 9. Root 5 times by root 5 is going to be, let's just keep it like this for now, root 25, so we don't have to worry about sorting that out just yet. Because you probably recognize that this is just going to be 5. And then 3 root 5 times by, let's see, we did first outside, so plus 4. So 4 times by 3 gives us plus 12. And then we only have the one radical, so 12 root 5. And then we want to do our inside value, so negative 4 times by 3 gives us negative 12 root 5, so just like we expected for these two to combine for 0. And then negative 4 times positive 4 gives us negative 16. Okay, so might have to start drawing longer fraction lines there. Now we want to look at simplifying this bottom term before we move forward. So our plus 12 root 5 minus 12 root 5 cancel out. So we have, I'm maybe going to go crossways so that I don't run out of room. 6 root 5 plus 8 stays the same on the top. And then on the bottom we're going to have 9 root 25 plus 12 root 5 minus 12 root 5 cancels out, so minus 16. Okay. Now if we want to simplify this, root 25, like we mentioned there, is going to be, so let's keep the top the same here, 6 root 5 plus 8 divided by 9 times by 5, which is 45 minus 16. And so then if we simplify that again, 6 root 5, 6 root 5 plus 8, and then 45 minus 16 gives us 29. So just be careful with this. Don't look and see, because we have a 16 here and an 8. Don't jump ahead and start trying to divide those. First of all, you need to make sure that you have the whole number on the bottom, because what we really have here is, this should be kind of like in brackets. So you need to make sure you know the full number here before you can start trying to divide with any whole numbers up here. So now that we have this as 29, you can see that these two don't actually divide into each other. So this would be our most simplified version. Okay. All right, next one here is 6 over root 4x plus 1. So again, multiplying by the conjugate, root 4x plus 1, so the conjugate will be root 4x minus 1. And we need to multiply the top by that as well, root 4x minus 1. Okay, so let's multiply out. So on the top, 6 times by root 4x is 6 root 4x, and then 6 times by negative 1 is negative 6. And then the bottom is going to be complicated again, so root 4x times by root 4x, just basically, I don't know, it's kind of up to you. What you could do here is, if you remember that multiplying these through is going to basically cancel out the radical, you can do that here. That's going to help you to skip a bunch of steps with simplification. If you don't feel comfortable with that, you can just multiply through the bottoms. So like 4x times by 4x would give you 16x squared. I'm going to do it the slightly simpler way, because you can look at the more complex one on the filled in notes. So I want to give this to you as a skip ahead in case you're comfortable with that. So root times by root cancels the root, so we have 4x. Okay, so that's our first times by our first, and then we want outside, so root 4x times by negative 1 gives us negative root 4x. And then our inside value, so plus 1 times by root 4x gives us plus 4x, plus root 4x, and then positive 1, so our last values multiplied by each other, positive 1 times negative 1 gives us negative 1. So again, negative 4x plus 4x are going to cancel out to 0, or add up to 0. So now we have 6 root 4x minus 6 divided by 4x minus 1. Okay. Let's see here. Now we just want to see if we can simplify anything else in here. So 4x minus 1 can't be simplified. They're not like terms. This radicand can be simplified because we have the root of 4, which would be 2, so we can go move the 2 outside. So 6 times 2 is going to be 12, and then the x has to stay under the root. And then minus 6 is going to stay the same, and then 4x minus 1. There we go. So that's our final answer for that one. Okay, so as you can see when we're working through this, there's multiple different ways that you can kind of approach this in terms of like, when do you simplify? Like we could have, taken this down as 16x squared and then simplified it further down. So there are different ways to kind of approach this, but just make sure as you go through and try these practice problems, which will be both multiplication and division. And when you go through them, just make sure you check your answers against the solution so that whichever method you're kind of getting into the habit of using, you can make sure that it is always consistently giving you the right answers, because that's the really important thing. It's not always the method that's going to matter. It's just that you have to make sure that the method you're choosing is mathematically sound and is consistently giving you the correct answers. Okay, so make sure you do that as you try those practice problems, and I will see you next time when we'll look at lesson 5.3, which is working with radical equations.